Hi, everyone. We're just going to give it a minute or two to get started. Okay, so welcome everyone. We're here to talk a little bit about chemistry, and we're talking about food science as well. So I'm going to be talking a little bit about the chemistry side of things. My name is Dr. Brock, or you can call me Dave. So big question I get asked all the time by people is, what in the world is chemistry? And really, there's so many different areas that you can study in terms of STEM, science, technology, engineering. You got material sciences, nuclear research, physics, nanotech, biochemistry, food science, medicine, engineering. But between all of these things, the core field that tends to tie all of these together is chemistry. Chemistry is very often referred to as the central science. So it's really the connecting, the glue that really brings these fields together. And really, you have collaboration, and in almost all of these fields, you collaborate with chemists in order to further your field. So chemistry is really has a kind of a hand in everything. So what exactly do chemists do, and why would you want to choose chemistry? Well, chemistry, if you look around you, like I said, people ask what in the world is chemistry. A better question is, what in the world isn't chemistry? Because really, if you look around you, everything has to do with chemistry. Chemistry has to do with synthesizing materials. So here we've got glutathione here, which is really used for your cell building up, repair, this sort of stuff. So we synthesize molecules. We develop new molecules. If you think of textiles, even how the paint sticks to the wall. How does the paint stick to the wall, but not stick to you when you touch the wall? All of these types of things is what chemists try and do. So chemists, we synthesize new molecules. We look at technology. How do we make technology smaller and smaller and smaller? How do you have a cell phone that can do all of these things, whereas a cell phone used to be this massive thing that you'd carry around before? Laptops, they've been getting smaller and smaller and smaller. How do you do all of this stuff? Well, it's really the chemical reactions that end up being able to do this. I should also point out, if you have any questions throughout the presentation, I will be taking questions at the end after Veronique's food science presentation. We'll be taking up questions for both of them at that point. But chemistry is also involved in implants in your body. It's also used in cleaning products, everything you can think of. Imaging. How do we image the body, image the brain? In terms of agriculture and foods, chemistry is at work in all of these things. But even beyond that, I hope students would take away from this, chemistry is important so that you also don't get taken advantage of. There's snake oil salesmen that sell things like colloidal silver and like, oh, this is a miracle cure. It'll cure shingles. It'll cure psoriasis, all of these different things. But if you actually ingest colloidal silver, it can actually result in argyria, where you end up actually developing, just like a photograph. That's how they used to develop photographs. Well, your skin actually does the same thing. So hopefully with a chemistry knowledge, you won't be taken advantage of by some of these things. Big question students are always asking. So what can I actually do with chemistry? Running joke I always have is, students coming out of high school generally have 4 ideas of jobs: doctor, teacher, lawyer, and fire person. And chances are, because you're coming to university, you've narrowed off fire person. But there's way more jobs out there than that, okay? So here's just a sprinkling of some jobs that you can do with chemistry. And because chemistry is so vital and plays a role into all of these different research areas, chemists are always in high demand. And it's actually a very small program. A lot of students are drawn to some of the other life sciences thing because they hear this medical term into it. So you don't have as large cohort of graduates. So these chemists that end up graduating from these programs are in very high demand, and they get called upon to be involved in a lot of these different career paths. So yeah, lots of different things that you can do with in terms of jobs. So what are the different programs that we offer here at Carleton? Well, you can do straight up chemistry. You can do an honors Bachelor of Science in Chemistry. You can also do a 3-year degree where it's a Bachelor of Science. This is just kind of an overview of what you would take. So you can see in red, there's a fair amount of chemistry that you would take throughout your degree because you need to get a good foundation in what chemistry actually is. So generally speaking, I know this can be a little bit overwhelming. So I really just want to focus more at the first year stage coming into university, kind of what would I be taking if I took chemistry? And whether you do chemistry with a concentration in toxicology or a degree in chemistry with a concentration in nanotechnology, or combined earth science or honors physics degrees, generally speaking, it's going to look very similar for the first year. Basically, you take your 2 chemistry courses, you take 2 math courses, and you take 2 physics courses. And then you have to take a few other courses to add up to 10 in total. But very often, students will take a couple of biology courses as well. And then they may take a couple of like psychology or something like that courses, or economics, depending on what you want to do, or electronics or something like that. But then generally speaking, you focus on more chemistry in upper year. And then if you're doing an honors degree, if you're doing an honors program, you would do your honors thesis, which are really awesome projects that you get to do in 4th year. That's where you actually get to do original research. You actually get to go into a professor's lab, and you're doing not the same experiments that people have done before. You're doing something brand new. You're doing something nobody's ever actually studied before, and you actually get to do novel research that nobody's done. So it's really cool. And students, if you're in an honors program, you're guaranteed to do one of these projects. So it's really hands-on work, really awesome for your degree and being able to do that. Okay, but like I said, there's some other things. If you want to do chemistry with something else, there's options of doing that as well. So there's also the options for doing co-op. So when we're doing co-op, typically you're doing the chemistry degree, but during your 4th year, you do a co-op work term. What's great about a co-op work term is you're doing the research, you're getting all the skills that you would normally get just by doing a chemistry degree, but you're actually getting in-person experience. Very often you can develop business relationships here. And oftentimes students who do very well in co-op can actually get a career in that field afterwards. They get offered when they say when you graduate, maybe you want to come back here. So in total, you have to do 12 hours of, 12 months of co-op. And students will often do this either in a single 3-month term, they'll do a 6-month term, and then a 3-month term, or they may even do a full 12-month term. So you can either do it in 1, 2, or 3 sections. In chemistry, you can start after your 2nd year, where you do a work term after your second year, or you can start in the summer after your 3rd year, and then during your 4th year, and then the summer after your 4th year. So there's actually 5 different opportunities, 5 kind of 4-month periods there, where you have to, during 3 of those 5, you would have to do co-op during those terms. But basically, so it is a 5-year degree rather than a 4-year degree because you do a full year of co-op. You can apply for this. Typically, you need to have in your major, in your chemistry, you'll need a cumulative GPA of your chemistry courses of 9.0 and an overall GPA of 7.5 to get into this. Students generally are expected to find their placement, but there is a co-op office, and you have help in finding these. So you're not kind of left on your own. There is the help to get those positions. And generally speaking, again, because chemistry is a smaller program and there's such a high demand for chemists, there's near 100% placement for students in chemistry co-op. So it's a really great opportunity to get firsthand work experience so that when you go out from university, you've got a leg up on the competition. So yeah, great opportunity there. Highly recommend and encourage that. So here's an example of some of the positions where people have gone to. They've gone to Health Canada. They've gone to RCMP Labs. They've gone to Natural Resources Canada, 3M Canada, Abbott. So petroleum industry in Calgary, National Research Council. There's lots of different opportunities for co-op students, especially here in the Ottawa area. There's a lot, but there's also opportunities abroad. So chemistry, I would really highly recommend if you're interested in. It's a great career path, but it's also gives you a great overall understanding that is valuable to anybody, I think. So now you probably might wonder why. Well, why should I choose chemistry at Carleton rather than chemistry somewhere else? And one of the big things about the chemistry department here is we have a strong research field, but a strong teaching focus as well. So in terms of research, we've got a couple of strong research areas. We have a section of our department that really focuses on materials for sustainability. That's a big thing in society nowadays, is this idea of being sustainable in our practices. So we've actually got a number of professors that do a lot of research in that area. So sustainable chemistry, sustainable, and coming up with materials for better aspects. So that's in terms of the material side of thing. You'll notice some of these people overlap because really chemistry is so interdisciplinary, and you saw that it tied in to so many different areas. But we also have a heavy focus on food safety, security, and analytical methods. So how do you actually analyze these different materials, and how do you actually look at the make sure things are safe? So we actually have a number of people in our department that are also focused on that, highly driven in that research area as well. Okay, the third area that we have a huge focus in is in human and ecosystem health. So health within our bodies, health within human bodies, but also health of our environment, which has got a lot of attention recently, especially with the fact that we have these issues with climate change and global warming effects. Really, we need to really have a better understanding of our ecosystem and the impacts that chemistry and society is having on that as well. Okay. And then, like I said, we also in our department, unlike a lot of departments, we actually have a strong focus on chemical education. So there's actually individuals in our department who, rather than being research faculty and teaching faculty, they're actually entirely focused towards chemical education. So we have, I'm one of these individuals here, where we actually focus all of our time and our energy towards purely towards teaching and the development of teaching and understanding teaching. So very strong aspect there. So why chemistry at Carleton? We've got a very strong teaching focus. I know some students you may have talked to have gone to university, and it's like, well, the professor I had, all they want to do is their research. They don't really want to teach. That's something I've actually taught at a number of universities. I've taught at McMaster, I've taught at Western, and I've taught here at Carleton. And that's something I've really found when I've come here to Carleton, is I haven't found a single professor in our department who isn't passionate about teaching and who really wants to be there to teach the students. So it's a breath of fresh air. I've really enjoyed it since coming here to Carleton, that there is this strong passion for teaching here. You also get to use, you also get to actually be involved if you want. Even in third and fourth year, you can actually get involved as a teaching assistant. So you can actually get, number one, paid to do this stuff. Actually, I should have pointed out as well, for that co-op term, you also get, while you're doing your studies and developing these skills, you also get paid for that to do the co-op term. So that's kind of pretty cool and fantastic. But you can also, even if you don't do the co-op route, or even if you do, in your third and fourth year, we actually hire chemistry students to help as TAs as well. So it's a good income, but you also get to develop skills that you wouldn't necessarily in other universities. Very often you have to be a grad student before you get to TA. So third and fourth year undergrads get to TA here. Another thing that we get to offer here at Carleton is the opportunity for exchanges. So you can do international exchanges. One of the tight ties we have is with the École Nationale Supérieure de Chimie in Montpellier, France. And we also have the Carleton International Exchanges, where there's opportunities in the UK, in the US, Australia. And so there are these opportunities that they already have in place. If you have ideas for additional ones, you can even bring those forward if you want to go to a different area. So there's those opportunities. And then another big thing that you get to do here at Carleton that you don't necessarily get to do at other universities is when you're actually training to become a chemist and you're using some of these very expensive equipments. Some of them cost on the order of hundreds of thousands of dollars, even into millions of dollars on these pieces of equipment. Rather than at some universities where you may just study the theory and be submitting your samples, here at Carleton, you actually get to run those pieces of equipment, which is really key, again, when it comes to trying to get a job. Not only can you say, yeah, I know how this thing works in theory, it's no, I actually have used this thing. I know how it works, and I could run that at your company if I had to get a job, or if I was in that role. I know how to not just interpret these things, but I can actually run them, which gives you a huge leg up again on competition. So some things that set chemistry apart from some other places. Also, coming into university, you can actually get a number of scholarships. There's a lot of scholarships. So you can get an entrance scholarship. If your average is over 80%, you can qualify for one of these scholarships that scales up based on how great your marks are coming in. And you can actually have it renewed and maintained over 4 years here at Carleton. So if you stay with a high GPA, to maintain it, you need to have this 80% average retained throughout, and then you're able to retain that scholarship. And over 40% of students do actually retain these scholarships all the way through. Say your marks weren't the greatest coming in, and that you improved afterwards. Happens all the time. Well, guess what? There's a lot of scholarships in the chemistry department. Because, like I said, there's so many career paths you can do. A lot of different individuals have actually donated to make scholarships after they've left. They've actually come back and given these scholarships. So there's a lot that the department hands out in all of these different things that they hand out to their students. And then on top of that, just by maintaining a high GPA throughout, you can qualify for these additional in-course scholarships. So there's lots of scholarship opportunities for students in chemistry. Even if you haven't gotten them coming in, once you're in chemistry, you can qualify for them. So lots of opportunities, lots of aspects in the department here. So just to give you an idea, some of the faces in first year, we've got Mastane and Vernon and Natalie, who are our lab coordinators for first year. I teach a lot of the science students. So if you're seeing me now, chances are you'll see me in first year teaching the science students. Dr. Burke tends to teach the engineers, and Alyssa also teaches one of the first year courses. So you're going to see us very often. How do we teach? Kind of fairly unique at Carleton is we use the flipped classroom facilitated by blended learning. So I'm actually, like we were talking about before, about the chemical education research. The way I actually teach in first year, and I've done this long before the pandemic ever hit, was I actually use a flipped classroom. So rather than just spouting information at students nonstop for an hour and a half, and then they go home and have to solve these practice problems where they never really process the material. And then they generally just hate chemistry because it's like, I don't know the material, can't solve the problems, and I'm just lost. What we do actually in first year is I've stripped all of the content out of the lectures and made fairly professionally made modules that they watch before class. And that frees up my class time where I can actually help students make the connections, see how they solve practice problems, tie it into real world application, and I can actually make it relevant to the students. And so the feedback I've gotten from students, so it's not less teaching, it's just a different way of doing the teaching so that students can actually go through the material at their own pace and process it. If something's not clear, they can rewind it, play it again, which they can't do to their prof at the front of the room. But it frees up that time where we can actually make those connections and make it relevant to students. And the feedback I've gotten from students anecdotally is that they find that it's like they love the chemistry lectures because they're like, I never realized why I should do this. I like a lot of students, PV equals nRT. I always ask my class, PV equals nRT. How many people have heard of that? And the whole class puts up their hand. And I'm like, who cares? And they start chuckling and laughing. I'm like, no, seriously, who cares? And I'm like, but how many people have heard of decompression sickness, the bends? And few people have put up their hand. I'm like, yeah, this is actually the ideal gas law in action. And so we can actually bring in these applications for it. And students really connect with that much more. So they're that much more engaged in class. They can actually see why they're trying to learn the chemistry, not that it's done in a vacuum. They're seeing, hey, this really applies to all of these different things that I'm learning about. And that actually translates into students doing better in this. I've actually been able to do some studies, and I've actually shown that this method has increased students' grades by a full grade point. So this is just to give you an idea of how do we actually teach at first year, okay? You're also going to get to use these state-of-the-art facilities. We've got this brand new or fairly new Superlab. It was renovated fairly recently. And you get to use these Superlabs. So you're actually getting to do the chemistry as opposed to just very often in high school, you read about the experiments. No, chemistry is about doing it. We want to get you hands-on. Okay? And then so for nanotechnology, what do we mean by a concentration in nanotechnology? So a lot of people don't understand scale. So when we look at scale, really when we look at the size of an ant, that's about on the millimeter scale. So that's really what we're looking at here. If we go to a pinhead, that's about 1 to 2 millimeters. So we're still up around here. When you scale down a human hair, we're starting to get on this 60 to 100 micron scale. So we're talking pretty small, but we're getting even smaller. You talk about micro electromechanical devices, MEMS devices. We're still orders of magnitude higher than nanotechnology. So that's 10 to the minus 5. We actually need to go down even farther. Here's red blood cells, which are about 7 to 8 micrometers. When we're talking about nanoparticles, we're talking about way down here. We're talking about nanotubes. We're talking about DNA, which is about 2.5 nanometers. So when we're talking about nanotechnology, we're talking about reactions, or we're talking about doing analysis at the nanoscale. So extremely small, and we're able to manipulate those things and study those types of things. So that's nanotechnology. And then when we talk about toxicology, really we're talking about different aspects. So sorry, I should say the nanotechnology. What we're really saying with nanotechnology, that's really 3rd and 4th year courses. So you take generally 1st and 2nd year courses, but then you're going to be taking some more electricity and electrical stuff in 3rd and 4th year. Whereas the concentration in toxicology also is more 4th year courses, 1st and 2nd year, but that's really dealing with, you can talk about environmental toxicology, industrial toxicology, when we're talking about pharmaceutical toxicology. Though all of those things would be discussed, really focusing on those aspects in the 4th year level if you're doing concentration in toxicology. Okay? So if you've got some questions, we've got a number of different undergraduate contacts here. We have Dr. Burke, who's our undergraduate advisor, Veronique, who's about to speak with you. She's the undergraduate advisor for food science. And then our undergraduate program advisor is acting as Emma Fraser currently, and then we're going to have Caitlin coming back soon. So that's all I have for chemistry. If you've got questions about the chemistry, I'll be taking those questions after Veronique talks about the food science, but she's going to continue on with the food science.
Hi, everyone. Can I get some thumbs up if you see my screen from? Yay. Okay. Thank you, David. So from one educator to another, I'm Veronique Bézard, and I'm the undergraduate advisor in food science, and I'm here to tell you about our program that is housed in the Department of Chemistry. So some might wonder why study food science or what is food science? And the answer to that is that the world is facing some pretty complex societal issues and that relate to food and how we feed ourselves. So first, some not so great news. About a third of the greenhouse gases that are produced by human activity are derived from food systems. So that's from the farm to the fork. So that's a third of our greenhouse gas emissions. So that's not very good. And on top of that, half of the food that is produced here in Canada is wasted, is not consumed. So clearly, there's room for improvement in our food systems. So we're wasting all this food, and at the same time, so many people worldwide are food insecure, meaning that they don't have sufficient access to healthy food on a daily basis. And that's not just in foreign countries. It is right here in Canada. It's in our northern communities, but also even here in our cities, in Ottawa. Um, and lastly, about one person in 10 um, every year gets sick from contaminated food. So, from either microbiological hazards or chemical hazards. So, clearly, there's a lot of work that food scientists can do to help this situation because let's face it, we're going to have to keep feeding ourselves for the foreseeable future. So the question is, what can I do? How can I learn to solve these complex issues? Well, here's a map of our program. Organized by year, and you can see here that it's spread out over 4 or 5 years should you choose to do co-op. But I also want you to know that there's flexibility in here. If you want to take 7 years or 8 years to do your degree, that's fine as well. If you're working part-time, you have other commitments, you need to take care of family, that's perfectly fine. You reach out to me, the undergraduate advisor, and I can help you plan a course sequence that meets your needs. So your first year is the foundation in biology, in chemistry, um, but also an introduction to food science with our first core, Food 1001. In second year, we're building, again, with a little bit more specific type of chemistry, like your organic chemistry. That's really talking about like the lipids, the proteins, the carbohydrates. That's the composition of your food. And analytical chemistry, because we need tools to be able to evaluate the composition and the safety of food. There's also some genetics and microbiology because if we talk about microorganisms in food, whether they are good or bad, we need to understand our microbiology. And genetics comes in handy when we're talking about genetically modified organisms. There's also some biochemistry because nutrition is at its base, it's biochemistry, it's nutritional biochemistry. And then there's our 4 courses in food science. And this is where you get to meet your peers, where you get to meet the students who are in your cohort. Um, and this is all, again, foundation for upper year courses in food science. So, nutrition, some food processing, some regulations because the food industry is one of the most regulated industry in the world. So to ensure that food is safe when it comes from any country in the world, it's important to be informed of those regulations because food scientists work within a regulatory context. And then we also have a scientific communication course that helps us communicate scientific information to the public. Right? As we saw, is really important. We saw this in the pandemic. Um, in third year, there's again a little bit about chemistry, but that's where you get into your food labs. So manipulating, carrying out experiments with microorganisms, with chemical reactions that are happening in food, um, with identifying the composition of food. So these are all lecture and lab based courses that you would take in in third year. And then in fourth year, we get a little bit more specialized with some toxicology, because if we're talking about food hazards that are entering your body, you need to understand some toxicology, some basic principles of toxicology. And then really the courses in food policies and risk assessment, those are what make our program unique, because we here at Carleton, we emphasize regulatory science, we emphasize food safety and the development of new food protocols, safety protocols, and food policies. And that's not something that we can do sort of in a vacuum. I hope you've noticed that our food science program is um, involves multiple disciplines, not just science. We offer some courses in philosophy, in economics, in policies. That's because if we want to solve these complex societal issues, we can't do so as um, we need to work with a multidisciplinary team. Uh, Scientists can't solve these issues by themselves on their own. Okay, so we want to mimic that environment that you're going to see when you enter the workforce. We want you to be prepared to interact with people from different viewpoints, different backgrounds, different areas of expertise. Okay. And so we also have the honors workshop that David mentioned for chemistry. So it's the same idea, but with food science profs. And then there's also co-op, which is an option. And David mentioned this as well. It's very similar. In our case, co-op starts after the third year of study, after you've taken these core food science lab courses. Okay, so this is a snapshot of our program. Um, and I've mentioned courses, some that are lecture based, some that are lab based. But if you're looking for additional experiential learning, there's a lot of options here at Carleton as a whole, but also in the Faculty of Science and in the Department of Chemistry. So the Dean's Summer Research Internship, that's a summer research opportunity for first year students. Um, iCurious and Student as Partners are university-wide programs to also carry out research with the faculty. And that research can be, in the case of iCurious, it can be it's lab-based research, whereas the Student as Partners is my favorite because it is working on educational or pedagogical research. So I love working with Student as Partners during the summer term or any term, really. And David mentioned the teaching assistantships that are available as early as second year, okay, and our capstone courses. So these are all great experiences that can help you cover the cost of your tuition and of your studies. And then, of course, we have co-op. So if you're looking at co-op, I won't repeat this information, but I do want to draw your attention to testimonials from our co-op students. And thank you, Stanley, for adding that info to the chat. You can see, you can read about what some of our students have been doing in terms of work placement. You might also wonder, well, okay, what will I do once I graduate? What does a food scientist do? And are there jobs? So good news is there are lots of jobs for food scientists. And during the pandemic, so over the past 2 years, 89% of our students were successful in finding work in their field of study or pursuing graduate studies within 6 months of graduation. So that's pretty impressive. There's a high demand for food scientists, and the great news is that the way we've built our program, there is no, you can find work immediately after your 4 year degree. There is, of course, if you're interested in graduate studies, we encourage you to pursue graduate studies, but with a 4 year degree, if we you have a unique skill set that is in high demand. Okay, and so again, I'd like to encourage you to check out our food science career series, where our alumni are posting about what they're doing now. And an example of this is Nikki. Nikki is working in the Bureau of Nutritional Sciences at Health Canada. So she worked on files like sodium reductions. She worked on caffeinated energy drinks. See, those are like nutrition issues that have a regulatory component to it. Um, Shiki is working as a a quality control supervisor. And so he's in the lab carrying out experiments to assess the quality of beverages at the LCBO. Okay. So there's a lot of entry positions in quality control in food science. And then Andrea, she's working at the Canadian Food Inspection Agency. So her work is more investigative. She's like a detective of food hazards that make their way into our food system. So she's trying to, when there are food recalls, she's investigating what was the entry point for that hazard? How can we prevent it from entering again? Um, and so this is just a it shows the broad range of opportunities that our students have been able to explore in their careers. So you might wonder, who am I going to interact with? Who's going to be teaching me? Well, here we are. This is the food science teaching team, teaching and research theme. And what I wrote here underneath in bold are the research expertise of our of our teaching team, because you can volunteer, you can work in the lab of one of your teaching members, and to gain additional experience. So Farah and Apollo, they work in what's called value added nutrition. So that's the idea of um, taking nutritional elements from food, often food that would be discarded, or food waste, or food byproducts. Take all the good stuff out of it, like extracts the fiber, extract the nutritional value, and then they reformulate it and add it to other food to boost the nutritional value of that food. So that's value added nutrition, and that's the type of work that Farah and Apollo are doing. David is working more in food safety, specifically like natural toxins. So there are toxins present in our food. Um, Naturally, they just belong there, but we need to monitor, we need to characterize their level. We need to characterize them and monitor the levels to ensure that food is safe. So that's the type of work that David is doing. Yaxi is joining us this July, and she's doing food adulteration research. And that's fascinating stuff. This is about like staying one step ahead of the food fraudsters who are trying to add, we'll say, chemicals or compounds in foods that really should not be in food, with the purpose of really financial gain. And so to be able to stay ahead of food fraudsters, we need to develop techniques, analytical tools to detect them. And so that's what Yaxi is planning on doing. That's what she's doing right now. Tyler does food security work, so he's our food microbiologist. He's using what are called like good microorganisms to fight off the spoilage microorganisms. And the beauty in it is that it diminishes our dependence on chemical pesticides, right? So, and it reduces food waste, because we know we want to reduce food waste. 50% is just way too much. Martha is our food regulation expert. She's trained as a lawyer, and I don't know what we would do without her. um, Trinda is our amazing lab coordinator, who you will see maybe in second year organic, but most certainly in your third year food labs. And then this is me, the program advisor and teacher of a few different courses in the program. I'm also the co-op coordinator. So if you have questions relating to that, you can reach out. Now, you might also wonder, okay, that sounds great, but like, how going to meet people? How will I make friends? Well, I have good news for you, and that is the Food Science Student Society. So this is a vibrant community. Um, they are organizing study groups. They are organizing career nights, trivia nights. They're there for to make the student experience an amazing one. And so this year, the president is Simon, and here are some of the third year, fourth year reps, and some of the executive members. They're I can guarantee you they'll be looking for a new first-year rep and a second-year rep. So I would encourage you to go and check out their webpage here to connect with them. You can connect with them right now if you want. Okay, so this is how you can stay in touch with us. And Stanley's been adding links to the chat. So that's wrapping up the food science program, but also the different programs in the Department of Chemistry that David covered as well. So at this point, I think we're ready to take questions if there are any.
So I noticed there's one question there, wondering about the class sizes, what they look like. So this is very common across many undergraduate universities. Is in first year, they tend to be a bit larger because generally anybody who's taking chemistry needs it for biology, biochemistry, chemistry. It's a huge plethora of students who take it. So they tend to be a bit larger. They're on the order of about 300 to 350 students, roughly, in those first year classes. But then after that, when you get into the upper year courses, they shrink right down because there's a lot fewer students in the programs, and they're usually about 40 to 60 or possibly even smaller, especially in third and fourth year courses. You may have 10 to 20 students in your classes. Yeah.
We're definitely on a first name basis with our students, and our students are with us. So in food science, first year course, there might be 60 to 70 students, but they're not. Some are taking the course out of interest and are not in the food science program. But in your second year and beyond, your food science courses would be around 20 students. So we like to call it a cozy atmosphere. It's cozy and it's great. We like it that way. So if you have a question, you approach your profs, and we have open door policies. We're you know easy to find and happy to answer your questions.
Yeah.
So it doesn't look like we have any more questions, but I just want to hop on and say a big thank you to you, David, and you, Veronique, for the informative and enthusiastic presentation. I'm sure our attendees are super psyched about coming to Carleton for both chemistry and food science. So big thanks to both of you, and a huge thanks to all of our attendees. We encourage you to continue to ask questions and continue to navigate our platform throughout today's March open house. So thank you once again, and have yourself an amazing, amazing day.
Yep.
Thank you.
Take care, everyone.